In this video, I am going to discuss about dipole moment numericals, which is frequently asked in NEET and mains examination. And next one, I am going to give what is this dipole moment? This is the topic. Next one, day 2 bond. Day 2 bond, also call it as coordinate covalent bond theory explanation, including competitive questions also I am going to discuss, students. First, let's begin with the dipole moment. In previous video, dipole moment theory explanation I had given. So please watch that video. Molecular orbital theory, paramagnetic, diamagnetic and dipole moment theory had explained. All symmetrical molecules, dipole moment is zero, everything. In this video, I am going to concentrate more numerical part. Okay. Now, first, let's begin with dipole moment questions. First question. First question. Arrange increasing order of increasing order or decreasing order. Anything you can take it. Increasing order or decreasing order. Here I am giving decreasing order. Here decreasing order. Arrange decreasing order of the dipole moment of following compounds or following molecules. Okay, I am giving 4 options here. What is this? One is CH3F, alkyl halide. Why I have selected this question? This is one of the frequently asking question, and that too exceptional cases there. Where exceptional cases are there, definitely those plays important role in our competitive examination. CH3Cl, next to CH3Br, CH3I. Clear, students? This one they are asking you to write decreasing order of dipole moment. Okay, first of all, what is dipole moment? Dipole moment is charge and distance. What is Q here, students? This is charge. What is D here, students? Distance. So finally, dipole moment depends on 2 factors. Okay, if you look into fluorine, students, highest electronegative element in the periodic table. Charge is nothing but here electronegativity. That's it. Electronegativity, right? So here is more electronegative. There is no problem. But size, distance is nothing but here we are considering the size. But as we move down the group, what happens, students? Size increases, but fluorine is small size. So finally, what I am trying to say here, if it is satisfying both the factors, then only dipole moment is more. But fluorine success where only one point, that is charge. But he failed where distance. Distance is nothing but here size only. But if you look into chloride, students, yes, it is satisfying both. So Q also satisfying, D also satisfying. Look into this CH3Cl, chlorine charge. What is this? 3.1. Even distance also large size. Right? As we move down the group, what happens? Size increases. It is compensating. It is fulfilling both the factors. That's why finally methyl chloride has more dipole moment. Afterwards, methyl fluoride. This is one of the frequently asking questions. Please note it down and keep it in mind, this point. Alkyl halides they are asking means exceptional. There is no exceptional case here. As it is, you can write, not an issue. But these two ulta because of this. Clear, students? That's all. Question 1 completed. Now, question 2, it's easy. So, try to give answer. Which of the following is least polar? Why I have selected this question? Easiest question only. But thing is, student is not reading properly. Which of the following is least polar? The word least they are not reading. Just they are reading polar and going for the selection of answer. If you will go like this, get wrong. Right? So let me give first options here. NH, okay, next OH, next CH, next HF. Okay, I am writing most electronegative elements, most electronegative elements, fluorine, according to Pauling scale. According to Pauling scale, students, fluorine is the highest electronegative element in the periodic table, not only that group. Next one is oxygen, that is 3.5. Next one is 3. And chlorine also almost the same, slight difference is there. But because of size, it is unable to show effective hydrogen bonding. Whenever hydrogen bonding is there, I can select such questions. Okay, now come back to this. Okay, now NH, OH, CH, HF, right? See, he is the more electronegative guy. He is also next most electronegative guy. He is the third most electronegative guy. Definitely, whenever hydrogen attached to these three, it forms strong hydrogen bonding. It forms here more polarity. See, plus minus, more polarity will develop. More polarity will develop. But if you look into what about hydrogen 2.1? 2.1, large difference is there, right? So CH here 2.4, 2.1. Electronegativity difference is there. It's not much. Polarity it can show, but it is not greater extent, right? So finally, what is the answer here? 3, right? So like that, we have to select the questions. If you have command here next to hydrogen bonding also, easy for you. Okay, students. Now going for the next question. Going for the next question, see, it is very easy, but seeing big structures, students will be scared. See, dipole moment of chlorobenzene. Dipole moment of chlorobenzene. What is chlorobenzene structure? This is benzene, here chlorine. That's it. Is 1.5 dB units. Okay. Dipole moment we are expressing in dB units. 1 dB, I will give you values also. Based on that also we have questions. 1 dB, 1.5 dB. Next, the dipole moment of hexachlorobenzene. Hexachlorobenzene. First, let me write the structure, students. Benzene, you all people know benzene. It is cyclic planar structure. Here carbon. Everywhere we have a carbon, right? Carbon, 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 carbon. Right? Everywhere hydrogen, benzene means. But here I am taking chlorine. Why? Because hexachlorobenzene, instead of hydrogen, I have written here chlorine. That's all, students. That's all. This is my structure. This is my structure. Or else you can write another way. Like this. Chlorine, 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 all chlorine, 6 chlorine. This is the perfect structure. Clear? To understand this one I have written, this is actually perfect structure. Now they are asking here, what is the dipole moment value? First option 0, second option 1.5D, same answer. And next to 2.86, and the fourth one they are giving 2.25 dB. Right? What is our answer, students? What is our answer? Symmetrical molecules dipole moment is 0. Previous class we have discussed, no? Next important point is para compounds. See, students, I am discussing one point here. See, this is benzene. If some group is there, some group is present on the benzene, with respect to this group I am speaking, this position is second position. Second position we call it as ortho. If you go for this way also, this is second position only. You can select like this. You can select like this. Okay, this is also second position only. This one we call it as ortho. With respect to this guy, the third position who is there, that is meta position. Here also this is meta position, right? And with respect to this guy, your fourth position that is there, that we call it as para. So ortho, next one para, next one meta position. Clear? Now I am going to give one more point. See, students, I am taking para dichlorobenzene. Afterwards, we'll go to our example. If I'll show at a time that one, you'll get little confusion. So, para dichlorobenzene, right? So, now look into this. Comparatively, chlorine, comparatively, this is carbon, right? This is carbon. Between carbon and chlorine, who is more electronegative? Definitely chlorine. So, the dipole moment direction we are showing. Yesterday's previous video I have given, no, dipole moment is nothing but vector quantity. It has both magnitude and direction. We are showing direction like this. This is exactly opposite. At least one exactly opposite cancelled by each other. Dipole moment is 0, plus 90 and minus 90, like that. Finally, you'll get dipole moment is 0. Right, students? Like that. The same way you can apply here. This is this direction, exactly opposite direction, cancelled each other. Next, this direction, this is like this. See, exactly opposite, cancelled each other, right? So next one, this is exactly opposite. See, exactly opposite are there. Dipole moment cancelled by each other. Then finally, what is our answer? What is our answer? First option. Clear? See, big structures, but simple. If you have logic points, if you have concept-wise knowledge, then any question which is very easy way you can handle, right? Now go back to the next question. Here percentage of ionic characters they are asking. Okay, and before going to that, let me give one more. Okay, see here, students. Cis dichloroethane and trans dichloroethane. Who is there in first year? As of now, you don't have much command in the cis and trans compounds. When organic chemistry starts, it will come. But who is listening now? Second year students, they already have good knowledge about cis and trans compounds. So whenever a double bond compounds is there, geometrical isomerism. So geometrical isomerism explanation time, we are using cis and trans, Z and E like that notations. To understand this one, I am giving 1 point here. Ethene. Simple way you can write, students. Ethene means double bond between carbon. Two carbons, the two carbons double bond, right? Dichloro. This is chlorine and here 1 chlorine. That's all. Remaining you have to fill with hydrogens. This is dichloroethene. This dichloroethene, cis dichloroethene, trans dichloroethene, in which case dipole moment is 0, they are asking. In which case dipole moment is 0. To understand this one, I am going to draw the structure in this way, right? So look into this carbon, it has 1 hydrogen, 1 chlorine, that you can write. It has 1 chlorine, 1 hydrogen, right? This carbon, it has 1 chlorine, 1 hydrogen. Okay, students, listen carefully here. So the similar groups on same side, write it down. Similar groups on same side. Similar groups on same side. Then what happened? What is this compound name? Cis compound. That's it. This is what we call it as cis dichloroethene. Dichloroethene only, but condition is cis condition. Why similar groups on same side? This is same side. You are also same side. If you write ulta, what is the next one? Can you try? Yes. C double bond C, and again we are writing this carbon having chlorine, this are hydrogen. This carbon also having chlorine, but exactly opposite you can write. That's it. See here, similar groups on opposite side. Similar groups on opposite side. So can you guess this one, guys? Opposite side. Then what we call it as trans dichloroethane, right? That's all. Can you try in which case dipole moment is 0? Maybe you got it answer, right? Look into this, students. Yes. Between carbon and chlorine, who is more electronegative? Chlorine. We can show dipole moment direction like this. And here also dipole moment in same direction, mu not equal to 0, mu not equal to 0. But here this is exactly opposite. See, exactly opposite. Definitely at least one will be in opposite side. Dipole moment is cancelled by each other, will get 0. Right? This dipole moment is not 0, trans dipole moment is 0. What is the reason? The last question. Cancelled by each other, opposite direction. Clear? Now, next one. Percentage of ionic characters they are asking. Percentage of ionic characters to understand. I'll give you some points here. Students, polar, non-polar compounds. Non-polar. I had given this explanation in the previous video, please. Chlorine, N2, O2, H2, F2. These are all non-polar. Why? Because same atom. 3.1 electronegativity, 3.1 electronegativity, no one attracting electrons, no one is giving, no one is attracting, no one is taking electrons, right? So mutually sharing, there is no charges, there is no polarity, no polarity, no polarity. Why reason? Due to similar electronegativity. Similar electronegativity, you and your friend, best friends are sitting, all you are sharing, mutual understandings are there. Now, polar. Polar is nothing but you and your enemy, like HCl molecule I am taking. Your electronegativity 3.1, 2.1, difference is there. Enemy, then what happened? He'll gain something, he'll fight, like, right? He's gaining electrons towards itself. Such a way, partial negative charge, partial positive charge develops. That's it. See, opposite charges are there, then you can say it is polar. Polar covalent bond. Polar covalent bond. That means what is this polar covalent bond? He is the guy 100% covalent. He is the guy 100% covalent, mutual sharing. But you cannot say here 100% covalent. So which is how much, which is more covalent, which is more ionic? Already have uploaded videos, students. Please go through that chemical bonding, I think part 4 or part 5, watch it. You'll get to know. And here what I am trying to say here, how much percentage also we can calculate, and measures also we can calculate. Students, suppose two different electronegativity. If two different electronegatives, if two different electronegative atoms are there, you can write like this. What is this? One you can take it as XA, another one you can take it as XB. This is like XA, this is like XB, you can consider. Now I am giving first point, case 1, XA minus XB. If you calculate the difference, 3.1 minus 2.1, so it is exactly 1.7. Then you can decide it is 50% covalent and 50% ionic. This value is fixed, students. Okay, with respect to this value, we are speaking. Now, next one, next point, what is that? Yes, second point. XA minus XB after calculation, electronegativity greater than 1.7. Then you can say it is more ionic, less covalent. Less covalent, right? Next, third one, XA minus XB less than 1.7. Then can you guess what is this? Exactly ulta of the 2 point. More covalent, less ionic. How much ionic percentage, how much covalent percentage, everything we can decide now. We'll discuss now. Okay, students, now can I start one question? Okay, before going to the question, I am giving important data to you, important points. Okay, so Debye units. I said no, dipole moment we are expressing, dipole moment in expressing Debye units. Okay, represented capitally. Okay, now write down 1 Debye equal to 10 to the power of minus 18 electrostatic units. Centimeters. This is what, students? CGS units. Okay. Next, 1 Debye equal to 3.33564 into 10 to the power of minus 30 coulomb. What is the students? Coulomb meter. Meters is nothing but this is SI unit. I am stressing this point. Most of the students, while taking selection of question and taking units conversion, is not doing in good manner. They're taking given question in SI units but selecting CGS units. If you take opposite, then final answer will be wrong. Okay, please note it down. Now we'll take one question. Okay, first let me give another point, another important point. Percentage of ionic character. Percentage of ionic character. How to calculate? Nu observed by nu theoretical. Nu is nothing but dipole moment into 100. New observed always they will give in numerical. Definitely they will give in numerical. Okay, here new theoretical into equal to Q into D. That is our formula. That is our formula. What is Q here? Charge. Charge of electron. Charge. Charge of electron. Okay. Charge of electron. So here 2 units, students. Electron charge equal to, this is anyone, are you remembered? Q equal to, what is the charge? 1.602 into 10 to the power of minus 19 coulombs, right? Coulombs, right? If this coulombs is SI unit, students, SI units. Then distance if they had given the distance they will give like 1 angstrom, or else distance they will give 5 angstroms like this, or 3.4 angstrom, something value. This angstroms we have to convert into meter centimeters. 10 to the power of minus 10 meters, 10 to the power of minus 8 centimeters, right? So if it is SI unit, even density also you can take it as 10 to the power of minus 10, right? Clear my point? Now, next important point is, if suppose Q equal to 4.8 into 10 to the power of minus 10 electrostatic units. Electrostatic units. If you take electrostatic units, this is also you can take it up. What is this? D. You can take it as 10 to the power of minus 18 electrostatic units. Electrostatic units. And the next one, if you have taken, this is meters. Meters means this value you have to take it. 3.33564. This value you have to take it. Here, meters means this value we have to take it. Now, next one, distance also. If distance, if you take this as CGS units, centimeters you are taking. Clear? If all should be in 1 unit, your answer will be perfect. I am repeating once again, new observed they will give in the numerical. That we have to take units, depends on this unit, Q and D. Q and D you are taking in SI units, this one also SI units. If you are taking this is CGS unit, this is also CGS unit. If you work out one question, you will come to know. Okay, little confusing, but don't leave. This is one of the important model. Okay, now look into this. One question I am giving. If bond distance is 1.34 angstroms and charge also they had given, sometimes they will give, they don't give charge is 4.8 into 10 to the power of minus 10 ESU, electrostatic units they mentioned. Calculate percentage of ionic and covalent character. Ionic and covalent character. Clear, students? That's all. So what is this percentage of ionic character equal to nu observed by nu theoretical into 100, right? So can you expand this one? Nu theoretical is nothing but what? Q into D. Okay. So now we can take it. Percentage of mu observed by theoretical is nothing but Q into D into 100. Mu observed, how much they gave students? Bond distance. This is D, right? Data. D equal to 1.34 and right? So next one, what is this next one? Here they have mentioned one more point. Experimental value they had given. Experimental value of dipole moment equal to 1.08 double. See, this is observed value. Observed value always they will give in the numerical. So, mu equal to how much? Mu observed equal to how much? 1.08 double. Clear? That's it. Now, next one, D you know. Next, what about Q students? See, Q they have given charge is nothing but Q, no? Q equal to 4.8 into 10 to the power of minus 10 electrostatic units. If you have taken electrostatic units are CGS units, right? So that is the reason. What is this? What is this? What we are taking here? 1.34 into 10 to the power of what are the values I had given?